I bought this 90s sign because of personal memories, although I knew it would need some work because of assembly mistakes. So the first time I ever saw neon signs on metal stick frames like this here in Germany were not beer signs but brandless themes like this USA flag, a Route 66 badge, the Dino Rocket with that planet, 50s drive-in, and 5 cents a dance. Those were the 5 signs that hung in a Burger King restaurant here, and it must have been 98. German beer neons at that time were usually in acrylic boxes and also just starting to appear. And those signs at Burger King all had the Eggtown 240-volt transformer and a sticker of that company Living Lights who sold them in Germany. But their stickers also had the web address livinglights.com. And that was actually the very first website that I have ever visited. In 98 or 99, I wired the phone line into my teen room to run a dial-up modem, and the first address I had in mind to try when it finally seemed to work was this one. And I remember that it took minutes to load all these miniature photos. This is actually the first sign with a Living Lights sticker that I ever found to buy, and the seller wrote it was buzzing and smelling of ozone, and I thought it's probably just this spot where the blue and red tube were touching in the auction photo. And I thought it was an easy fix, just get a bit more distance in there. I already started reworking the sign late at night when I came home before I decided to record it, but I'll tell you what I found. At this point, I'd like to mention my video about neon transformer wiring do's and don'ts that I'll link in the video description. I explain why and where you need to keep space between tubes of different voltage potentials and tubes to metal, and why you need to find a right wiring sequence for the sign. We have 5 tubes on this sign. The USA portion, red short stripes, white short stripes, red long stripes, and white long stripes. This tube is red neon gas in a white tube painted over with red paint. And this one must have been remade at some point because it's real a red color glass, and I think it has blue gas and white phosphor in it. And it also has a fresher blockout paint than all the other tubes. I've already moved the tubes apart in various places, and you see that the blockout paint and red paint has been burned off by the voltage difference and the small arcing between the tubes. Like here all the red paint is missing, and then we have blockout paint missing down here on the white tube, red paint burned off here, red paint burned off here, blockout paint burned off here, and so on. And if that wasn't bad enough, we also have several spots where the tubes almost are completely touch the metal tube supports. So there's one here. I already removed a few. This support was touching the electrode glass here. There was another one behind that was touching this glass where the blockout paint also is burned off. And these are all avoidable spots. They could have just put a bit more thought in it and placed those supports on other places. So to remove that problem with the high voltage differences between tubes really close to each other, I changed the sequence. This was already good. We have the short white and short red tubes connected to each other. Then I also did this to the long red and long white tubes. They are now also connected to each other. So I'm coming out from the transformer into the long white tubes, through the long red tubes, then over to the short red tubes, short white tubes, over to the USA flag, and then back to, the USA badge, and then back to the transformer. So besides buzzing like a Tesla coil, the sign was flickering in brightness when I got it. And on core and coil transformers, that's usually a sign of barely enough voltage to still illuminate the tubing length. It's a bit better now because it has warmed up. But it didn't go away when I changed the wiring sequence, so just the additional load from the buzzing was not the only problem. Over the tube life, the electrodes are aging and they will release small metal particles, which is called sputtering. Those metal particles will encapsulate gas atoms and decrease the amount of gas that's available in the tube, and that will increase the necessary voltage to run the tube. There's an ideal gas pressure for each tube's diameter and length, and that's where the lowest point is in that curve. But we start off with more voltage requirement. That is because we put a bit more gas than ideal into the new tube, so we get a bit of lifespan reserve or buffer. So during the first few thousand hours, some gas atoms will be taken away by the sputtering, and we get to that ideal operating point, the lowest point in the curve. And then when more gas gets locked away, the voltage requirement goes up again until it reaches a point where the tube does not strike anymore. So either the tubes have aged to a point where they need more and more voltage to turn on, or the transformer itself has a problem. It is an Eggtown American transformer, but designed for 230 volt 50 Hz, so that should not be the problem. It's designed for the European power grid. And I tried running the sign with a 9 kV electronic transformer and that worked, but with the added test resistor or just a 1 foot extra tube, it will already cause a turn off of the transformer, so it's just on the edge. Now I'll let it run a bit and then we check with the thermal camera if we find a tube or an electrode that runs hotter than the rest. And while that runs, we can test the Eggtown transformer. It's now lighting up on this solid state transformer, and I have isolated the Eggtown to do some measurements. So to find out if it probably has a problem with the internal windings, I can do a short circuit current test, and that should give me the current reading, neon current reading that's on the nameplate. And it shows 15 milliamp, and that is exactly what's on the plate. So that should be okay. And now I'll test the open secondary voltage, and that should also be exactly what's on the nameplate. And it is. We have exactly 9 kV on this analog meter. So from the first side, I think this transformer doesn't have any internal faults. And now another test that I can do is measure the actual running voltage of the neon, because it will be less than the open secondary voltage. It will drop to a certain amount, and there's a factor. It's around about 60 to 65% of the ignition voltage or the open secondary voltage on blue gas, and about 55% of the open secondary voltage on red gas. So if I turn this on now, we have the sign buzzing and flickering again, and we have 9 kV reading again. So that is too much. It should be only about 65% of 9 kV. But it reads 8.5 kV, so this probably means that the tubes have just aged to a point where they need more voltage. And even a 10 kV Avatron goes to hiccup mode after a few minutes. And then I went through thermal imaging, and you see that the tubes all have round about the same temperatures. The red gas would have been okay to have a bit more, but they are all around 40 Celsius, 100 Fahrenheit, and the electrodes are all around 55 to 75 Celsius, so that looks good. But then I actually found something that was off, and that is the USA batch tube. So the frame has 57 Celsius and the lettering even has more than 70. So that's a good indicator that this tube has a problem. Although its light still looks okay, it pretty sure requires more voltage than it should, and the electrode is also running pretty hot. And you see that even better when I shift the color palette of the thermal image. So now the stripes tubes are all black because they're all colder, and the whole USA tube shows up hotter than the rest. And those colorful spots in between the stripes, that's the electrode heat. So you know I'd like to keep the originality of the sign by keeping this transformer case with a sticker, but yeah, you see what it does. But at the moment this is the only transformer that fits in the case, but it doesn't have enough power. So repairing that USA part hopefully will bring the power consumption down so far that I can still do this retrofit with the modern transformer in the original case. So I will keep you updated on this one.